Synthetic division. All right, so remember, so this is a different method for doing long division. Instead of doing long division, you can use this process called synthetic division. I have a feeling once you've learned it, you're going to probably want to use synthetic division most of the time. It tends to be more efficient, easier to use. There are cases where using long division will be much, much easier, particularly in situations where you will end up with fractions. So you definitely don't want to just throw out long division. It is very useful in certain situations where synthetic division can get really messy. So remember that when you are dividing by x minus a, that means that a is positive, because remember that was like x minus positive a. And that when x plus a, that meant that a was negative because it was x minus negative a. And we've done so much work with those that should be just absolutely second nature and common knowledge to you now, that when it's x minus a is positive, and when it's x plus a is negative. It's always the opposite. So that's important to know, because when you're doing synthetic division, you have to set it up a specific way, and the first way is to place the divisor in a box. And so the divisor is really what you're placing in the box is the root. So you are testing the root in the division, which means you're testing the factor. Okay, so you put in the box what the root would have been. So if this is x plus 1, has to be a negative 1 in the box. Okay, so this is where you put the root. And so remember, you need to do the opposite of positive 1 to get negative 1. Make yourself a note of that off to the side of your paper somehow, that it's opposite in the box. Okay. So step 1, look at x minus a, place a in the box. Okay, so remember, use opposite sign. Maybe that would be a good place to put the note to self, that you're going to use the opposite sign. Now, put a box around this plus 1 and note that you put a negative 1 in the box. Then what you do is you list all of your coefficients in order. The big thing here is that use placeholders for missing values. Okay? So for example, this one starts off with an x to the third. So I always like to do this: x to the third, x squared, x to the first power, and then my constant. That way I know I don't forget any. I go right down the line in order, and I make sure I don't forget any. Sometimes when you're looking at these examples, you're going to have something missing. The next example will be where we need to place a placeholder in. So you'll have this first example, just how to do the problem. Then the second example will be, what do you do when you're missing something and you need to use that placeholder? This is a strategy I use, listing this at the top, and then I don't forget. So the coefficient for my x to the third term is 3. My x squared term is negative 4, then 2, and then negative 1. The signs go with the coefficients. We don't need the variables. I just use them there as sort of my column places, so I know where I'm putting stuff. And then here's the process. It's the same every time. You're going to drop the first number. You are going to multiply by the root, and then you are going to subtract. And then you are going to repeat. Okay? So make some space, drop the 3. Multiply it times the root. 3 times negative 1 is negative 3. And then you're going to, I shouldn't say subtract because that confuses people. Let's say combine. Let's change this to not subtract, but combine. That will be better. Combine. So you have negative 4 and negative 3. That gives you a negative 7. Negative 7 times negative 1. Negative times a negative is a positive. 7 times 1 is 7. put it here in the next column. Combine. 7 plus 2 is 9. 9 times negative 1 is negative 9. Combine to get negative 10. You box off that last term because this box, this last one, is always your remainder. And what the 3, the negative 7, and the 9 represent are the coefficients of the term of the polynomial that's left. Okay? So if you had an x to the third and you divided out an x, you would be left with an x squared. And so this is going to be 3x squared minus 7x to the first plus 9, remainder negative 10. This will be your answer. When you divide 3x to the third minus 4x squared plus 2x minus 1 by x plus 1, you're going to get 3x squared minus 7x plus 9, remainder negative 10. When you take the x to the third and you divide out an x to the third, divide out an x, you're going to be left with an x squared. So this first term, the lead term, is always 1 power less than original. Okay, it's always going to be 1 power less than the original. And then those numbers represent the coefficients, and you just go right in descending order from there. So x squared, x to the first, and then 9. Okay? Let's talk about the second example where we need a placeholder. So again, we're dividing by, we have to put a 3. This is a positive 3, so I have to put a negative 3 in my box. I'm starting with an x to the fourth. Then I'm going to do x to the third. That's a third. Then I'm going to do x squared. Then I'm going to do x. And then I'm going to do my constant. So 4, 3, 2, 1, constant. X to the fourth has a coefficient of 1. X to the third, I have none. This is where my placeholder comes in. I need to put my 0 in there. X squared, I have 3 of them. X to the first power, I have 1. And my constant is 4. And then from here on out, it's just the same as the last example we just did. We're going to make some space. Drop the 1. 1 times negative 3 is negative 3. Negative 3 plus 0, or combine, is negative 3. Negative 3 times negative 3 is positive 9. Combine, 9 plus 3 is 12. 12 times negative 3 is negative 36. Negative 36 and 1 is negative 35. Negative 35 times negative 3 is positive 105. Combine to get 109. So remember, this is your remainder. And these are the coefficients of the x terms. If this was an x to the fourth, started off as an x to the fourth, then this is going to be 1x to the third minus 3x squared plus 12x minus 35, remainder 109. There's your answer. I leave a little space over here. Note to self, we had x to the fourth. X to the third we didn't have, so we needed a placeholder. Right, so this was a 1. And then this was a 3x squared, and this was a 1x, and this was a 4. So just don't forget about your placeholder. Very important not to forget about your placeholder. Okay? So, remainder theorem, if a polynomial p of x of degree n greater than or equal to 1 is divided by x minus a, where a is a constant, then the remainder is p of a. Huh? What does that mean? So, let's talk about this. Every time I read that to my class, everyone always just stares at me because no one seems to know what in the world I just said. So let's talk about this. If a polynomial p of x of degree greater than 1 is divided by x minus a, so they're just saying if you just did some division, right, where a is a constant, and you got a, where a is a constant, then the remainder is p of a. So they're saying if you are taking that number, dividing by, let's say you're doing this division. Let me try to find you a good example. So if you're taking 7, right, and you're dividing out 7, and so A is the constant 7, then the remainder, you do all this division, blah, 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 and you get your little remainder box over here. This remainder is going to be the same as if you had just said P of 7. So if you had just said, take 7, plug it into the equation, chug out the answer would equal that same number, the remainder. So the remainder theorem is saying that you are able to figure out whether or not 7 is a factor or not. So remember, when you do division and you get a remainder that is greater than 0, it's not a factor. If you get a remainder of 0, it is a factor. Then they're saying that this remainder theorem is a way to know whether or not that A term that you just divided into that polynomial is in fact a factor. So remainder P of 7, right, means that if you plugged P of 7 into the equation, and it equals 0, right, so you've got a remainder of 0, then that means that x minus 7 is a factor. So remember that the root, remember this was the root when we were dividing. So that would be the factor x. If that's a plus 7, it would be x minus 7. And if when you plugged in 7, you did not get 0, so this time the remainder is not equal to 0, then x minus 7 is not a factor. Okay? So if you take a root and you plug it in and you get a remainder of 0, then that is a factor. You just have to remember that when you write it as a factor, x minus or x plus, that you're using the opposite symbol, right? So we're going to check to see if in fact -4 is a root, right? So we're going to use synthetic division. We're going to actually plug this in. This is the root, -4. So we're going to leave it the way it is. We don't use the opposite symbol here because it's already in its root form. It's not given to you as a factor. So you don't have to worry about switching the sign. X to the 4th is 1. X to the 3rd, I don't have any. X squared, -5. X to the 1st is 4. And then the constant is 12. Ready? Drop down the 1. 1 times -4 is -4. -4 plus 0 is -4. -4 times -4 is positive 16. 16 and -5 gives you 11. 11 times -4 is -44. -44 plus 4 is -40. -40 times -4 is positive 160. And then 160 plus 12 is 172. So P of -4 does not equal 0. So it's not a factor. Let me see. I should change that to say not a root. Okay? It's not a root, which means that x plus 4 is not a factor. Okay? X plus 4 is not a factor, and -4 is not a root because my remainder is not equal to 0. Okay, let's do this one. -1. Again, 2 x to the 4th, 6 x to the 3rd, -5 x squared, 0 x to the 1st, -60 constants. Don't forget your placeholders. Really, really important. Drop your 2. 2 times -1 is -2. 6 and -2 is 4. 4 times -1 is -4. Combine gives you -9. -9 times -1 is 9. 9 and 0 is 9. 9 times -1 is -9. combine to get negative 69. Again, p of negative 1 does not equal 0, so it's not a root, and x plus 1 is not a factor. It would have to equal 0 in order for it to be a factor. Okay? So, special cases when the divisor has a leading coefficient greater than 1. All right, so we talked a little bit earlier about sometimes how using long division is a little easier. Some students really prefer long division as opposed to dealing with fractions and things. Sometimes these can get really sloppy. So here's the special case with synthetic division. You have to be able to do the division when the coefficient in front of the x term is greater than 1. We haven't done this yet, but what has to happen is you have to divide the entire problem by the lead coefficient to make it equal to 1 first. So this has to happen first. All right? That means the entire equation. So you have to do 2x to the third plus 9x squared plus 14x plus 5 divided by 2x plus 1. So if you need that lead coefficient to be a 1, you have to divide by 2. And if you divide that by 2, you have to divide every single term in the entire equation by 2. The problem is not all of them divide out evenly. So we get x to the third plus 9 over 2x squared plus 7x plus 5 over 2 divided by x plus 1/2. Then you do your synthetic division with these numbers. So you have to put negative 1/2 in the box, 1x to the third, 9 over 2x squared, 7x to the first, and 5 over 2 for your constant. Drop the 1. So those of you who hate fractions are shuddering right now, and you need your fraction key to help you. 1 times negative 1/2 is negative 1/2. So if you do 9 halves minus 1/2, that gives you 8 halves. And that, 8 over 2, simplifies to 4. So I'm going to use 4 and not 8 over 2. 4 times negative 1/2. So half of 4 is 2. It's going to be negative. 7 minus 2 is 5. And then 5 times negative 1/2 is negative 5 over 2, or negative 5 halves. These cancel, give you 0. So remainder of 0. So this is awesome because we now know that 2x plus 1 is in fact a root. My answer is going to be x squared plus 4x plus 5. When I do the division, this is what I get as my answer. And I know that I can continue to factor this down if I wanted to. I'm just showing you how to do the division, but at this point I know that 2x plus 1 is one of my factors, and that this x squared plus 4x plus 5 is another factor that I will then break down and be able to figure out what my roots are. Right? This is the whole process we're using. All of these techniques, the synthetic division, is going to help us to figure out our roots of these polynomials a lot easier. So that's using synthetic division. Here's using long division when you have a problem like this. So you do your 2x plus 1, and then you do your 2x to the third plus 9x squared plus 14x plus 5. Okay? So for those of you who really, really, really dislike fractions, what do you multiply 2x to get 2x to the third? I already have the 2. I already have 1x, so I just need an x squared. Right? And that gives me my first term. So x squared times 2x plus 1 gives me 2x squared plus x squared. Do my subtraction. 2x to the third minus 2x to the, oh, sorry, that's a 2x to the third. X squared times x. This is an x to the third. 2x to the third minus 2x to the third cancels. 9 minus 1 gives me 8. X squared. Drop the 14x. What do you multiply 2x by to get 8x squared? So 2 times 4. I have 1x. I need one more. So I'm going to do 4x times 2x plus 1. 4 times 2 is 8. X times x is x squared plus 4x. Do some subtraction. 8x squared minus 8x squared cancels. 14 minus 4 gives me 10x. Drop the 5. What do you multiply 2x by to get 10x? Well, you already have the x, you just need the 5. Then you do 5 times 2x plus 1 gives me 10x plus 5. Do your subtraction. 10x minus 10x cancels. 5 minus 5 cancels. Remainder 0. X squared plus 4x plus 5. My remainder is 0, so I do know that 2x plus 1 is a factor. Again, I could keep factoring it down and get my zeros, but this is the answer to my division problem. And they are the same. The question is, which method do you prefer? If you really, really dislike fractions, as soon as you see that the coefficient's going to have to get cleared, then go ahead and use long division if you don't like to deal with the fractions. If you're totally fine with dealing with the fractions, then you divide everything out, plop it into synthetic division, and work your way through the problem. Just be very careful about the fractions.